This is term 1 week 5 whatever mechanics whatever. Projectile motion and closest approach to the same material as the periodic. These are the formulas over here. If you want to take a screenshot, whatever you want. These are the formulas. Anyways, the first one they say, these graphs are very important. I guarantee you at least one of them is going to come tomorrow. Okay, they say a projectile is launched. You know it's projectile. Type, they're asking you about three things. Tamam? Vy. If you scroll down, they say Vx. And then A. Type. You need to know in a projectile motion, it's something being thrown. So it's gonna have an acceleration that pulls it back down. And this A is equal to negative G. What's G? 9.8. So it's gonna be negative 9.8. Why is it negative? لأنه it's slowing down. مش صح as you throw it up, it stops at the top and goes back down. Exactly. So A is equal to negative G, which is negative 9.8. Okay, so A will be constant, which is negative 9.8. So it's not changing, A is constant. Alright? طيب, Vy, مش you start at a specific velocity and you start slowing down, right? At the top, Vy is how much is at the top? Do you know how much? It's 0. Exactly. So Vy, it starts slowing down. So Vy is equal to negative Gt. Why negative? It's to show that it's slowing down. Well, this is our formula here. Where is it? Vy is equal to negative Gt plus V naught sine theta. Anyways, so Vy will be decreasing. How about the x component of the velocity? X component of the velocity will always be constant. And it's actually equal to what? V naught cos theta. Anyways, so knowing this information, let's choose the graphs. For the y component, like I told you, it's going to be decreasing linearly. Not curve, it has to be a line. Okay, decreasing. You might ask, why is it not this one? No, it doesn't decrease, it doesn't start at 0. If it starts at 0, it starts going down to negative. That's not how it works. Okay. Part B, they said the x component. X component, I told you, Vx is constant. So which is going to be? It's going to be the constant horizontal line. Okay? Easy. How about the acceleration? You're going to tell me acceleration is constant. So how do I know which one to choose? This one or this one? It's going to be this one. Because acceleration is negative. Exactly. Negative 9.8. Question 2, same thing. Now they're saying select the graph that describes the variation of the horizontal velocity. Again, we said the horizontal velocity Vx is constant. So it's going to be figure B. Perfect. Alright, nice and easy. Question 3. Basically, when you see a question like this, okay, they're going to give you a lot of values, whatever. And they say, what's the speed of B relative to A? It basically means VB A. Okay, this is the first step you write. And VBA means V of first one minus V of second one. Tamam, this is your first step. Now you have to figure out what each one is. But they gave you the velocity, they gave you the angle, for all you have to do is split it up into components, like I did here. But don't forget, it's to the left, huh? Y to the left, as a Y negative, it's negative, but why negative? Because it's pointing to the left. Other people, like I told you, instead of 65, they use 115, because that's the angle with the x-axis. You can do that if you want. But if you want to use 115, don't make it negative, you keep it positive. But now I'm using 65, I'm making it negative. So you can do cos 65 and keep it and make it negative, or just make it 115. Anyways, and then 0.8 sine 115 doesn't matter. Then same thing with A, split it up into x and y component. Then do VB minus VA. VB minus VA, and you do the x components minus each other, you get negative 0.77. Then the y components minus each other, you get 0.47. Then they said speed, so what do? You take the magnitude, and you get 0.9. Here, projectile is launched at an angle alpha, given by tan alpha is equal to 5/8 at a speed of 17. So they didn't give you the angle, but they gave you tan alpha. They gave you the angle theta or alpha, whatever. So alpha is equal to tan 5/8, tan inverse 5/8. And V node is equal to 17. Tamam. They gave us G and whatever. They want the range. What's the range formula? V node squared sine squared theta. V node squared sine squared theta over 2G. So it's gonna be 17 squared. Let's find out what this angle is. Yeah. 32. 17 squared sine squared 32 over 2 times 10. Perfect. 17 squared sine 32, and like I told you, when you do on the calculator, you put it all squared over 20. So you get did I do something wrong? Sorry. This is the max height formula. My fault. So what I did now, I read part B. So I did part B. This is part B. They want range. Range is, sorry if anyone's watching this. Range is v naught squared sine 2 theta over g. So it's gonna be 17 squared sine 2 times 32 over 10. So it's gonna be you get 26. Easy. Okay, here you have a particle P, mass 0.1, moving in a circle of radius 2 meters per second. Sorry, 2 meters. Radius cannot be meters per second. At a constant speed. Its period is 6 seconds. When we say period, it means it's not the other period that you're thinking about. It's period, yani the time taken for one full revolution. Okay? That's what a period is. Anyways, take pi as 3.14. They said, what's the speed of the particle? Let's take a look. They want v. It's the speed. V is equal to 2 pi r divided by t. Frame this formula if you want. Now, what does this mean? You don't need to memorize it. Really, you don't need to memorize it. Velocity is distance divided by time. Right? طيب. They gave me a time 6 seconds. So it's going to be something over 6. What's the distance traveled in 1 second? It's one full circle, right? Because the period is the distance for one full circle. And what's the distance of one full circle? Isn't it the circumference of the circle? Yes. So 2 pi r. Okay? So 2 pi r over 6. So it's going to be 2 pi times the radius 2 over 6, which is 2.09. Okay? Which is to the nearest integer 2. The angular velocity of the particle to the nearest integer. Angular velocity also has a formula, 2 pi over t. Realize how there's the only difference between angular velocity and normal velocity is the r. Same thing. Okay? Why again? The formula for angular velocity, the original one, is the change in theta divided by time. The time they gave us is 6 seconds. How much change in angle did it change in 6 seconds? It was one full circle. And how much is one full circle? That's 360 degrees. But I know we work in radians, and that's 2 pi radians. Okay? So 2 pi over 6. Okay? So you get pi over 3, which is to the nearest integer 1. The centripetal acceleration to the nearest integer. Alright? Centripetal acceleration can be v squared divided by r, or r omega squared. We have v, we found it. We have omega, we found it. And we have r. So you can use any of these two formulas and you're going to get 2. Let's use the first one. We found v as 2, so 2 squared divided by 2, which is 2. And r omega squared would be 2 times 1 squared, which is 2. Okay? So, nice and easy. Alright, so over here you have a particle initially at point 40. So I wrote it here, 40. Is undergoing a uniform counterclockwise circular motion. So it has a circle and it's moving along a circle with its center at the origin, moving at 2 pi meters per second. So this is the velocity, 2 pi meters per second. So this is the speed. Every second it's traveling 2 pi. So you could say that the position or the distance traveled would be 2 pi times the time. But we don't care about that. Let's forget about that for a second. Anyways, they want the position of the particle at t equals 1 and then t equals 4. Now, when you see this in an exam, anytime you see x equals 4, y equals 8, it's just nice to draw the coordinate plane. تمام? طيب, at t equals 1 second, the particle would have traveled 2 pi. Why? Because the speed is 2 pi per second. So 1 second, yeah, it would have traveled 2 pi meters. And we're moving counterclockwise. So it's gonna go like this. But the question is, where will it end? You know, after 1 second, where is it gonna reach after a second? So here's what you think, okay? Now, the way I thought about this is, you'd want to see how much is the total distance of the circle. The total distance of the circle is its circumference, which is 2 pi r. Okay, now, they didn't tell you the radius, but come on, it's kind of obvious. They said the center of the circle is at the origin, well, this is a point here. So how much is this? How much is the radius? 4. So it's going to be 2 pi times 4, which is 8 pi. So this is the full circle. Okay, this is full circle. How much did we travel in the 1 second? 2 pi. Top 2 pi out of 8 pi. Isn't that quarter circle? طيب يعني you reached where? Here. Okay, and what's this point? 0, 4. There you go. How do I know this is 4? Because the radius is 4, so if it's 4 here, then up here it has to be 4. Okay, the velocity of the particle at t equals 4 seconds. You need to know that in a circular motion, velocity is the tangent to your trajectory. Okay, so obviously the velocity is gonna be 2 pi, but 2 pi, that's the magnitude of the velocity. But how do I know what to put in the pi, in the I, what to put in the j? If we were here, what would the tangent look like? Like this, صح? And in this case it would be 2 pi I or j I, because it's horizontal. Let's say I was here, it would be a mix between I and j. If I was here, it would just be j because it's vertically downwards. Here, again just I because it's horizontal. Here it's a mix. They want at t equals 4 seconds. So you need to know, first of all, where am I at t equals 4. So what do? Again, we go into our velocity. At 4 seconds, and you would have traveled 8 pi meters. And didn't we find out that the full circle is 8 pi meters? Yes. So if you're here, you travel 8 pi meters, where are you going to end up again? The same position. So what's the tangent at this point? Like this, vertical, right? So that means it's only has a j component, and that is 2 pi j. 0 I. There's no I. Type. Here we have a particle moving along the circle. Radius is 10. They gave you frequency is equal to 2.0 hertz. Okay, and they want you. They said it's moving clockwise. I don't care. But the speed of the particle. Type speed. Earlier I gave you the formula 2 pi divided by t. Now this is the same thing as saying 2 pi times 1 over t. 1 over t, if you know what that is, that's frequency. Okay, so it's the same thing as saying v is equal to 2 pi f. So over here I can use this formula, v is equal to 2 pi f, and get v is equal to 2 times pi times the frequency, which is 2 pi r. This was 2 pi r, not 2 pi. I'm saying I'm missing something. Okay, 2 pi r, right? So 2 pi r over t. So it's actually 2 pi r f. So 2 pi r f. 2 pi times the radius again 10. You got this? Okay. 2 times 2 times 10 in terms of pi. We want to keep it in terms of pi. So we leave the pi to the side. 40. Alright, the position of the particle at t equals 4 is given by what? Type. Initially the particle is on the positive y-axis and moving clockwise. So we start over here on the positive y-axis. So this is where we start. If we're on the y-axis, how far are we? The radius is how much? 10. So we're over here at 10. Okay, and you can kind of like draw a circle. Okay, and we're moving clockwise, so it's gonna go like this. Anyways, they're saying the position of the particle at t equals 4. Type. We figured out that the speed is 40 pi meters per second. So at t equals 4, we would have traveled 160 pi. Now you need to know, okay, I started here. I travel 160 pi, where am I gonna be? Let's take a look. I told you the step you do after this is figure out how much is the circle. So the circle is 2 pi r, so it's 20 pi. So you divide 160 pi always. You divide this by this, you get 8. So that means you did 8 complete revolutions. You get me? So 8 complete revolutions. Okay, you revolved. Yani where do you end up as your initial point? Same as your initial point. And what's that coordinates? 0, 10. So this is correct. Okay? Then they said the velocity of the particle at t equals 4 is given by what? This is the same as the last question. Same thing. You just need to find the tangent at t equals 4. Tangent to the trajectory. Right? Type. What's nice is we figured out in the previous part where the particle is going to be at 4 seconds. And we figured out it's going to be here. The tangent is just going to be like this. Right? And that's horizontal. So no j component. So it's just going to be 40 pi, I, and 0j. Got it? Yeah. Alright, the initial velocity of a particle is this, and it moves uniformly along a radius of this. They want the angular velocity. Now, they want omega, you have v, you have r. You need to know that v is equal to r omega. This is angular. This is tangential. The same way you convert from angular speed to tangential speed, you multiply by r. Same thing, converting angular acceleration to tangential acceleration, you also multiply by r. For r is kind of like that thing that separates angular and tangential from each other. Okay? Anyway, so this is the formula. V is equal to r omega. So if you want to find omega, it's just going to be v divided by r. V is 3i minus 4j. Can I work with a vector? Never. So radical 3 squared plus 4 squared, which is 5. So it's going to be 5 divided by r, which is 0.2. So you get 25 rad per second. The magnitude of the acceleration of the particle is what? Type. Acceleration in circular motion has two components. A centripetal, or other people call it a normal, and a tangential. They have the specific formulas. تمام. أول شيء you need to know that it's moving uniformly along a circle. Okay? For our level, moving uniformly, we're most of the time going to work with only uniformly along a circle. But you need to check. If they tell you accelerating, they give you the acceleration. That's, they could say alpha is equal to 0.5. That's the angular acceleration. Alright? But now they're saying moving uniformly. So is there alpha? It's not accelerating. What does that mean? Which acceleration is equal to 0? The tangential one or the centripetal one? Tangential. Okay? So AT is equal to 0. But A centripetal and A normal, whatever you want to call it, they will always follow this formula. Okay? In this case, we found this. So we can just use it. So 25 squared times 0.2. And you get 125. Okay? Got it? Alright, 9. The centripetal acceleration of a particle with radius 20 is equal to negative 4i minus 3j. So this is negative 4i minus 3. This is the centripetal acceleration. The speed of the particle is what? Type. How do you relate speed? V. Radius r and a centripetal. Didn't I say AC is equal to v squared divided by r? Yes. So v is equal to RAC all under the square root. Just rearrange this math. Take this there and square root. So it's going to be square root of the radius 20 times 5. Lay 5. Because this must be, you must get the magnitude out of it. So the magnitude is 5. If you don't know it already, get used to it. Anytime you see a vector 3, 4, always the magnitude is 5. Anytime you see 6, 8, always the magnitude is 10. These are ones I مش memorized. بس خلاص I got used to them. No fast, I don't waste my time. So root 100, which is 10. The frequency of the particle's rotation to one significant figure is what? Again, v is equal to 2 pi r f. So 10 is equal to 2 pi 20 f. So 10 over 40 for 1 over 0.25. So 0.25 divided by pi is equal to f. And you should get this number, 8 times 10 minus 2. Yeah, so 8 times 10 minus 2. Alright, now we're back to relative velocity. This is very easy, really, guys. You need to take your time, don't panic, just write down everything step by step. A car is traveling with velocity 7i plus 5j in the vicinity of a train whose velocity is negative 5i minus 4j. the velocity of the train relative to the car. So what do they want? V train with respect to car. So VTC. And what is this equal to? What minus what? VT minus VC. Okay? So what do we need? V train minus V car. What's V train? Negative 5i. Negative train. Negative 5i minus 4j minus V car. 7i minus 5j. You know why it's minus minus, yeah? Because I distributed the negative inside here. Minus 5i minus 7i minus 12i. Minus 4j minus 5i minus 9j. Got it? Nice and easy. Then the speed of the car. How do you do this? And you should get 15. Alright, a plane is flying with a velocity of 10i minus 20j relative to the ground. So we're just going to say v plane relative to ground. When they say this, write it down. Sometimes you just say v train. They just, like in the previous question, they just said the velocity of the train. Here they're saying plane relative to ground. So write it down. So vpg 10i minus 20j. To the plane pilot, a cart on the ground appears to move at negative 3i plus 4j. So, a cart on the ground, velocity of the cart is negative 3i plus 4j. They want the velocity of the cart relative to the ground. If you realize they said to the plane pilot, the cart appears to move at. So is this cart moving with relative to the ground or with relative to the plane? What? No, the cart is moving at negative 3i plus 4j. Relative to what? To the ground or relative to the plane pilot? They said to the plane pilot. To the plane pilot, it appears to move at this. So that means it's not actually moving at this, but the guy who's flying the plane, it looks like this. So that means this is the velocity of the cart in front of who? In front of the plane. Or pilot, whatever. Okay? What do they want? They want velocity of the cart relative to the ground. Tight. This, it's so easy. Usually, you do this. صح? So what you're used to doing is VC minus VG. But here it doesn't stand because we don't have VC minus VG. So anytime you see in the question relative to, make sure you're writing down the given. VPG, VCP, whatever. Okay? Relative to the ground, yani plane with respect to ground. VCP, yani plane, cart with respect to the pilot. تمام? Type here, this doesn't work. We don't have this. What do you do? Like I said, going back to grade 10. What's vector AB plus BC? Isn't the answer to that vector AC? Don't you take first and last letter? Even if you have AB plus BC plus CD plus EF, what would the resultant vector be? AF. Okay? Always. So, basically what I'm trying to tell you is I want to write this as a sum of two vectors that will get me CG. So, according to the logic I just said now, shouldn't it be a vector that starts with the two vectors? Shouldn't the first vector start with C? Shouldn't the second vector end with G? According to exactly. Which vector here starts with C? This one. So V, CP. And which vector ends with G? PG. Yeah? The CP isn't really PG. Anyway, so VCG is equal to VCP plus VPG. What's VCP? Negative 3i plus 4j. What's VPG? 10i minus 20j. Okay, so negative 3i plus 10i, 7i. 4j minus 20j minus 16j. Wallah, not hard. This is the hardest part. This is literally just writing it down is the hard part. Speed, magnitude. I won't waste my time. Okay? So, velocity of the boat relative to yacht is 16i minus 8j. Like I told you, anytime you see relative in the question, you have to write it down like this. Boat relative to yacht. So we're going to use whatever letters you want. VBY is equal to 16i minus 8j. Tamam. According to the compass of his yacht captain, his vessel is moving due north at 20 meters per second. Do you know what this means? How can you write this down as a vector notation? 0i plus 20j. Okay, but what's this? This is his vessel. So this is according to the compass. They want the boat relative to still water. Okay, his vessel. What does vessel mean? طب هنا they couldn't use simpler English. طب هنا they want V boat with respect to water. I think here when they're saying yacht's captain, okay, and they're talking about the vessel. When we say vessel, they're talking about the yacht. Okay, so V yacht with respect to water. Yeah, because his vessel is moving due north. So when you're looking at the compass, yani it's with respect to the water. So 0I plus 20J. Okay, what's this? That means we need our first vector to start with B and our second vector to end with W. So isn't this just VBY plus VYW? Exactly. What's VBY? This 16I minus 8J plus 0I plus 20J. So you're gonna get 16I plus 12J. And then speed, تاخد الماgnitude. So just take the magnitude, it will become 20. Capiche. Yalla 13. We're flying. The velocity of a particle is given as VA equals minus 3I plus 4J. With the velocity of A relative to B is 2I plus 5J. The velocity of particle B relative to the stationary reference frame VB is equal to what? Type VAB. What does VAB mean? Do we have here A relative to ground, something relative? Nothing. Okay, we just have two things related to each other. Okay, what's VAB? VA minus VB. What's VA? Negative 3I plus 4J minus VB equals VAB, which is what? One more time, VA minus VB, so VA, which is this, minus VB, which we're trying to find, equals VAB 2I plus 5J. Then you solve. Okay, don't forget, it's always first minus second. Rearrange it now. You're gonna get, let's take VB there. You're gonna get 5I, no, negative 5I, and then minus J equals VB. So this is your answer. And then speed, degree, just magnitude. So far so good. It's not that hard, yani, I'm not gonna lie. Okay, same question almost. Chip A is moving at a constant speed of 10 on the bearing of 127 degrees. Okay, hello, we're going back to grade 11 mechanics, bearings. Okay, we'll go slowly, but let's do it. Let's read the rest of the question. Ship B is moving at a constant speed of 5 meters per second in the direction of north 53 degrees west. So I'm going to draw another diagram here for it, and then we're going to fill them in a sec. Just 1 second. What do they want? They want velocity of A relative to B. So VAB, which is what? Do we have in the question relative to, relative to, relative to? Do I have any of that? No. So which one do I use? Do I find two vectors? No. When I don't have relative to, only here I have relative to. That's when I just do VA minus VB. Tamam. We need to know what's VA, what's VB. They just gave us a magnitude and an angle. Magnitude and angle. We need to split it up into X and Y. Right? VA, they told us it's 10 meters per second, 127 degrees. Type bearings. How do you draw a bearing, ya khayi? Bearing. Now, I gave you this rule last year. It still works. If you want to turn it into X component, let's say VAX, we do 10 cosine the angle, right? Yeah. And VAY is 10 sine the angle. But the problem is here, they gave us a bearing, they didn't give us the angle. I told you last year, to convert from bearing to like the theta that we actually use, you just do 450 minus the bearing. Okay? And in this case, this is last year's stuff, but you still need to know it. I assume you know it. 323. So 323, 323. And whatever answer you get, we plug it in. But let's now find VB. They said north 53 degrees west. Yani you go to the north, you go to the west. You start at north, you go how many degrees in the west direction? 53. So it's gonna look like this. So, no. So what angle is this? Isn't the angle we take always the angle with the x-axis? Yeah. So how much is that? 90 plus 53, which is 143 degrees. So for VB, the x will be 5 cos 143, VBY will be 5 sine 143. So let's add up the x components and then write the answer, and then the y components and write the answer. So 10 cos 323 plus 5 cos 143. You get, that ain't 12. Oh, we're supposed to subtract. Yeah, we're supposed to subtract. 12. Yeah? So this minus this, let me write it. 10 cos 323 minus 5 cos 143 equals 12, almost 12. And then 10 sine 323 minus 5 sine 143 is approximately, you should get negative 9, but let's do it. Okay, 10 sine 323 minus 5 sine 143, negative 9. So you get 12i minus 9g. Speed, exactly. Magnitude. Tamam. Easy. 15. Alright, this came last year, so we're gonna do it slowly. A boat is trying to cross a river in which water is flowing eastward at 3 meters per second. What does eastward mean? Yani 3i plus 0j. Type. This is velocity of what? Velocity of water with respect to what? هلا انت اكيد you don't know it's a respect to question لانه you still didn't read the full question. So let's say you're in the exam, you wrote this. Let's continue. The boat is moving relative to the water at 10 meters per second. You know. Now you know what? We're working with a question where you have to do respect to, relative to. Okay. Here they said boat moving relative to water. So this is V, B, W equals 0I plus 10J. So if this is VBW, what's this VW? It can't be VWB because that doesn't make sense. BW then WB. You could say with respect to, since here they're asking to the shore, let's say it's respect to the what? Shore, or to the ground, or whatever. It doesn't really matter. Okay, that's literally how you do it. They want boat's velocity with respect to shore. So they want VBS. Again, we're doing a respect to question, relative to question. So can I just do VB minus VS? No, I can't. Okay, so I need to find now two vectors, one with B as the start and one with S at the end. Which one's B at the start? This one here, 0I plus 10J. Which one's S at the end? This one here, 3I plus 0J. So it's gonna be 3I plus 10J, and they want the magnitude for بسرعة. Yeah. Now, to determine the boat's direction, if I'm not wrong, you do shift tan, but I just need to make sure, because when I did it in class it was different, but I need to make sure. Yeah, it is. Okay, so you just do shift tan. This is our famous formula from grade 10. Tan inverse y over x. Right? So 10 divided by 3. 16. Oh, this one, how many times did I solve this question? So many times. Yeah, let's do it fast. So a boy kicks a ball vertically upward with an initial speed of 12. So V node is equal to 12. And it's important to note vertically upward. So theta is equal to 90 degrees. Express numerical answers up to one decimal place, whatever. Express the velocity of the ball in terms of time t. So, velocity, this is a projectile. Velocity takes two components. Vx, Vy. Now, since we're going vertically upward, Vx is equal to what? 0. Always. Vy is equal to what? What's the formula? Minus gt plus V node sine theta. Okay? Minus gt plus V node sine theta. So it's going to be minus 10t plus the initial velocity is what? 12 sine 90. So minus kif sine 90 is 0, sine 90 is 1. So minus 10t plus 12. Determine the time it takes for the ball to reach its maximum height. There's a formula for this. T max is equal to V node sine theta over G. So we're gonna say 12 sine 90 over 10, which is 1.2. Another way people do is they equate this to 0, because at the maximum height, how much is Vy? Vy equals 0 at the maximum height. So they just equate this to 0, which is also correct, doesn't matter. Type, express the position of the y in terms of t. What's the formula for the position y? It's minus half gt squared plus V node sine theta t. So it's going to be minus 5 t squared, because minus half times 10 is minus 5, plus V node sine theta, so 12. Sine 90 is just 1, so there's no need to write it, so 12t. Okay. Determine to one decimal place the times t and t prime at which the height is 6.2 above its release point. So we found this. All they're saying is height is 6.2, so y is equal to 6.2. So minus 5t squared plus 12t is equal to 6.2. Quadratic equation, it's not hard. Okay, yes, so bring the 6.2, it's quadratic, so minus 5, 12, or minus 6.2, you get 1.6, to one decimal place it's 1.6, or 0.75. Sorry, to one decimal place that's 0.8, yeah. Alright, 17. A projectile is launched, again I solved this for the mechanics periodic, is launched at 20 meters per second, making an angle of 53 degrees above the horizontal. Take g is equal to 10 and consider the origin at the initial location, whatever, choose the positive. Okay. They want x. What's the formula for x? Ignore everything. It's v node cos theta t. Alright? So 20 cos 53 t. 20 cos 53 is 12. So it's going to be 12 t. So this is why. Did we get any t squared? No. Did we get any constant term? No. It's just 12t. Type y. What's the formula for y? It's minus half g minus gt squared plus v node sine theta t. So it's going to be minus 5 t squared. Why minus 5? Because minus 10 times half is minus 5. Plus v node, so 20 sine 53 t. 20 sine 53 is 16, so it's going to be 16t. So minus 5t squared plus 16t. Did I get any constant term? No, no constant term, so that's why I put 0. The time the projectile remains airborne, so they want t total. This is different than the time to reach maximum height. This is 2 v node sine theta over j. So 2 times 20 sine 53 over 10. Alright, which is 3.2. The range, what's range? R is equal to v node squared sine 2 theta over g. So it's gonna be 20 squared sine 2 times 53 over 10, and you get 38. A river flows due north with a speed of 1.2 meters per second. Okay, so we're gonna say, okay, let's continue reading, then we'll see something else. A man rows a boat across the river, with the river is 1,000 meters wide. So let's look at this. Alright, 1,000 meters. وشكله he's rowing the boat. Yeah. Okay. The man decides to row the boat with a velocity of 2.4 meters per second due east. How far north of his starting point will the man be when he reaches the opposite bank? Choose the correct answer. Okay, this is actually a very nice question. Basically, they want how far north of his starting point will the man be. So you have this river flowing north at 1.2 j, right? They said north, so it's 1.2 j, and we have that the man is going east at 2.4 I. So what's his resultant velocity gonna be? 2.4 I from the boat, and the river pushing him up 1.2 j. صح? طيب, let's take a look. They're saying how far north of his starting point will the man be when he reaches the opposite bank. Isn't the resultant velocity gonna be, is he gonna go directly east? No. Since he has some j component, that means he's gonna go like this. Right? He's gonna end up here instead of ending up here. You need to use trigonometry here. You have this side is how much? 1,000. We're trying to find this side here. So this is the angle here. صح? Okay. And we want the opposite side. We have the adjacent side. So what am I going to use? Tan. Okay. How أصلا am I going to get the angle? Don't I have the y component and the x component of the velocity? Can't I just do that theta is equal to tan inverse 1.2 divided by 2.4, which is 26.5? 26.6 or 26.6. Yeah? طيب. So that means tan 26.6 is equal to the opposite, which is the height, north, over 1,000. So do tan 26.6 times 1,000, 500. Here, they want us now to start at an angle. Okay, again, same river, 1,000 meters. Okay, we want to row at an angle such that شو اسمه such that you end up over here. Okay, so we want to row at an angle. Obviously, we know we're gonna be pushed up. The river is gonna be pushing us up with 1.2J. Okay, so if someone's pushing you up, you're gonna want to start. If you start horizontally, will get you to push up. Will cause you to be pushed up, and you're gonna end up somewhere here. Starting vertically will get you to be pushed up so far up. So what's the solution if you want to end up somewhere here? You'd want to push down, right? Push down. Okay, so you're gonna want to push like this. Okay, and what velocity again are we using? It's 2.4. It's he's not changing. Okay, this push here is still the same push, 1.2. The river isn't changing. The river didn't say, oh, now we're on hard mode and he's gonna push more. No, it's the same thing. All you have to do now is just calculate the angle. You have the opposite and you have the hypotenuse. So sine theta is gonna be equal to 1.2 over 2.4, opposite over hypotenuse. So theta is equal to 30 degrees. Simple as. Alright, body of mass 5 is thrown upwards with initial speed, whatever. Thrown upwards, yani theta شو 90 degrees. Type the highest point that the body reaches is what? V naught squared sine squared theta over 2g. Perfect. So it's gonna be 20 squared sine 90 squared, yani, over 2 times 9.8. You get this value here. The time to reach this altitude, T max. How do you find T max? Simple as V naught sine theta over g. If they said total time, what do? You multiply this by 2. Okay? Type, so V naught sine theta over g, يعني 20 sine 90 على 9.8, and you get approximately 2. Okay, you get something very close to 2. The time it takes for the body to reach half the maximum height. Okay, there's no formula for half maximum height, and you don't divide this by 2. Please do not divide by 2. Okay, don't. Okay, half the maximum height. What is the maximum height? 20.4. Yani we want y equals 20.4 over 2, which is 10.2. We want y equals 10.2. What do? Y is equal to what? Minus half gt squared plus v naught sine theta t. Yalla, you have to solve it. So 10.2 equals minus 4.9 t squared. I hate keeping the g. So quickly I get rid of it. 9.8 divided by 2 is minus 4.9 plus v naught sine theta t. We want to find t, so it's a quadratic equation. So simple. Okay, go here. Mode 5 3 minus 4.9 20 sine 90 is just 20, then minus 10.2. So you get 3.5 and 0.6. Which one do you choose? They said to reach it for the first time. So you take 0.6. That's it. Okay. About projected at 25 meters per second with an angle 37 degrees. Yeah, so a ball is projected at 25, angle is 37, whatever. Speed of the ball at the topmost point. V at maximum height. You need to know what velocity you have at maximum height only. Vy, 0. Vx is the only speed at max height. And what's Vx? Vx is equal to V naught cos theta. So it's going to be 25 cos 37, which is 20. The greatest speed attained by the ball while it's airborne. Always take it as a rule for me. If it's a symmetrical parabola or symmetrical projectile, the greatest speed is the speed you're starting at and ending at. If you're starting at 25, here you're also going to finish at 25 because it's symmetrical. Exactly. If it's going down, then you need to do this equation. But I doubt he's going to get it in the CA. The trajectory of the ball. Trajectory of the ball, memorize it. I'm not going to waste time. Minus g over 2 v naught squared cos squared theta x squared plus tan theta x. So you substitute the value. So it's going to be, I'll just put it in the calculator to save time. Minus g, so it's going to be mode 1 minus g, which is in this case 10, over 2 v naught squared, yani 25 squared, times cos 37 squared. You get minus 0.125, there you go. And then tan theta, so tan 37, well, you get 0.75. Easy. Alright, for this one here, this I don't know if it came, I don't know, but it came in the CA once. The angle above the horizontal, what do you do? Now, sometimes it might not be like this, and you have to use the formula I used here, the trajectory formula, minus g over 2 naught squared cosine squared theta x squared plus tan theta x. Use that. But here, to find the angle, you don't have v, alright? So you can't use the trajectory formula. But they gave you y, and they gave you x, and they gave you a tangent line. So all you have to do is take a point on that tangent line and do tan alpha is equal to y over x. So tan alpha is going to be equal to 20 divided by, this is 0.5. No, this is 1, this is 0.5. Okay, so you get alpha is equal to tan inverse 40, and you get 88.6. The initial speed of the projectile. There's so many ways to do this. Now, I like doing this. I now have theta, which is 88.6. This y is the maximum height. 80 is equal to the maximum height, which is what? V naught squared. Sine squared theta, so sine squared 88.6 over 2g, and g is what? 9.8. Now you can solve easily for v naught. 80 times 2 times 9.8 divided by sine 88.6 squared, close bracket. You get this, now root it, you get 40. The time the projectile remains airborne, time total, is what? 2 times or 1, or just 1 times? 2 v naught sine theta over g. Make sure you guys memorize the formulas. So 2 times v naught, which is what? 40, sine 88.6 over 2 times 9.8. You get 8. Cheeky. Hey, sorry, why did I put 2? Alright, the speed of the relative airplane relative to air. So airplane relative to air, I'll take it like this. You can use other letters, like it's not a rule. Okay, is 300, and the diagram is shown below. And wind blows in a perpendicular direction. So this is velocity of wind. You could say wind with respect to ground. Okay, is equal to 50. Doesn't matter. Anyway, part A, select the diagram that shows the direction in which the airplane moves relative to the ground. Now, obviously, if you have something like this, you have a vector like this, what's the resultant vector going to look like? It's going to look like this. It's not rocket science. Okay, the resulting speed of the aircraft relative to the air is what? Okay, now for part B, the resulting speed of the aircraft, again, you just sum them. Okay, you could say this is 300i. Now, I know it's not horizontal, but they said it's perpendicular. So you can actually rotate this like a bit, and it's going to look like this, because they're perpendicular. Okay, so since they said it's perpendicular, rotate it a bit, it's going to look like this is air, plane, this is wind. Alright, anyways, so you get this, and you can just sum them, and it's not hard. 300i minus 50j, and then to find speed, what do you do? Radical. Alright, there you go, 304. Last question for today. A swimmer oh, I remember this question from grade 11. Same exact question, I did it, and I didn't know how to solve it in the recording. Moving at 10 meters per second perpendicularly to the bank of the river. Okay, the width of the river is 250, and the speed of the current in the river is 0.6 meter per second. Perfect. Can you, until now, we have this moving to the right, we have this moving down. The time it takes the swimmer to cross the river, given to the nearest integer, is what? Type. We have a distance, we have some sort of speed, and we want time. So speed is just equal to distance over time. So time is equal to distance divided by the speed. The distance is 250 meters. The speed is a vector. We gotta figure out what the speed is, okay? The speed right now, or the v actually, is 0.6i plus 2j, right? We need to find the magnitude, so it's gonna be 0.6 squared plus 2 squared, so radical 0.6 squared plus 2 squared, it's gonna be let's say 2.1, okay, 2.1, so over 2.1, and you get approximately 125, okay, nice and easy. The distance that the swimmer covers as she crosses the river is what? Now, here is the swimmer. Obviously, she's not moving straight. She's moving something like this, yeah? So we need to find out what this is. Obviously, we have that this is what? 250, right? We know this is 250. Okay, we need this. So we have the adjacent. This is the adjacent side. This is the hypotenuse. So I need cos theta, because cosine theta is adjacent over hypotenuse. Now how to find cos theta? First let me find out what is theta. How do I find tan theta? Tan theta is y divided by x. What's my y? 2 over 0.6. Alright, so let's find theta. Shift tan 2 over 0.6. You get 73.3. So theta is equal to 73.3. So now cos 73.3 equals adjacent, which is 250, over x, whatever the distance is, the hypotenuse. Yeah. How do we find it? Take if you don't know, you take x there and cosine 73.3 there. It's a trick in math. Okay, so you do 250 divided by cos answer. Whoa, I'm not supposed to get that. Okay, I just figured out why it's sine instead of cos, because this theta 73.3 is not this angle here. It's always the angle you get with the x-axis. So this is the 73.3. Okay, so this angle here, the one that we want to use, is 90 minus 73.3. So I can't use cos 73.3. I have to use 90 minus 73.3. So let's try that again. 250 over cos 90 minus 73.3. Oh, so I have to. And you get 261 meters. هيك بنكون خلصنا guys. Thank you so much for watching and good luck in your exam.